So my area of research, currently the focus is lung cancer research. So lung cancer kills more New Zealanders than any other cancer, more than breast, prostate, I think pancreatic, not colorectal, that's another biggie, and melanoma combined. 5 people a day. Now, most of that's due to smoking, but about 20% isn't. And the people that who are not smokers who get lung cancer tends to be of a type where we're now finding in the last 5-10 years can be treated by particular drugs which target these mutations that drive the cancer. And now the one I'm studying is a particular type of lung cancer which has a protein in there, a mutated protein called ALK, and we study the way that works and how the drugs which block that protein treat lung cancer now in those patients. Now it works pretty well for most people, but only temporarily. So typically within a year there's a relapse. We're trying to figure out why that is and how to prevent it, how to overcome it, particularly with combinations with other drugs. That's our focus. Long-term impact is to answer that question and to basically funnel ideas into clinical trials and impact upon people's survival. And more broadly, it's a general principle for all similar cancers which are driven by a particular mutated protein which have the same sort of problem. Things like Herceptin are similar with breast cancer, similar idea. It's a very clear question and a very sort of not only scientifically but clinically, socially, very clear sort of outcome that we're sort of reaching towards with real world impacts. But also it's a field which is generating a lot of ideas very quickly. It's moving ahead very quickly, and it's not easy, but relatively easy to generate ideas and to move forward in new experiments pretty quickly. There's general principles about how this resistance to the drug happens, that if we can get the general ideas worked out for this cancer, that may be applicable, translatable to other similar cancers. I like interacting with smart young people. That's basically I think that's the top thing about being an academic scientist. You're dealing with very intelligent people, young people who are dynamic and energetic, and there's not just the supervisor driving them. It's a two-way process. So they bring an energy that, you know, as a middle-aged person, you can really feed off, and I think that's the best part of the job for me. Pharmacology and toxicology is the most practical interdisciplinary of all the medical sciences. You can study pharmacology and toxicology and you can go out into many different types of job. I would say personally it's just highly interesting and fascinating, and pharmacology, how drugs work, how poisons work, it's just interesting for its own sake. But if we look at a broader, you know, what are people going to do afterwards as a student? Well, our graduates, our postgraduates, pretty much go into work that's very closely related to their areas of study very often. I just had a master's student just finish on this topic that I've told you about. She's gone into a job more straight away with a clinical research company in Auckland, and that's not an atypical story.